Hello everybody, this is the first of the online lectures for Math 127 Elementary Cryptography at Christopher Newport University in spring 2020. We have moved online due to the COVID-19 pandemic, and well, we're just going to see how this whole thing works. We are going to be starting midway through the lecture entitled More Modular Arithmetic. This is where we left off in class. The slides are available on Scholar, and I recommend downloading them. Also, just to provide authenticity for you, I am going to be drinking coffee while I record this, so expect pauses and it should give you some ambiance of the regular class. Also, I want to apologize in advance for the rough delivery. Due to time constraints, I will not be editing these videos, but focusing on content versus delivery. I would suggest that you have the slides available to write notes on, as well as having Mathematica open with the MCP evaluated as we go. When we were last in class, we had discussed how to find the GCD of two numbers using the Euclidean algorithm, and we're starting to look at how to find the inverse of a number mod n. So that is where we are going to pick up about halfway through the slides. So this is where we left off. We actually got a little further than this, but I'm just going to backtrack a little for the sake of continuity. This is slide, I think, number 42 in the PDF file. All right, the thing that we need are these two results. One that we can, once we find the GCD of two numbers, we can recover it as AS minus NT for a couple of integers, S and T. The important fact for us is that if we have 1 equal to AS minus NT and we reduce mod n, this term will drop out and we will see that we get S is going to be A inverse. So our goal is to find those numbers S and T. Okay, I mentioned this in class. There are two ways to do this. One is called the extended Euclidean algorithm. Requires more work and time than the Euclidean algorithm, but it works all the time. There's also something called a Euclidean table. This is done using the quotients from the Euclidean algorithm, which you've already done in order to find the GCD. It doesn't always give the correct answer. Half the time it will give you the right answer, half the time it will give you the wrong answer roughly, but when it does give you the wrong answer, it's easy to fix. So for the sake of efficiency, we're going to go with the second. It just requires less time. All right, so what we do is we start by computing the GCD of the numbers A and N. Remember, we're trying to find A inverse mod n. So if that GCD is anything other than 1, it's not invertible and we throw it out. Now, we use the Euclidean algorithm, which is essentially repeated division with remainder. And we should get down to this last statement where we get a remainder of 1. That's what tells us that the two numbers are relatively prime and A can be inverted mod n. We don't use that last division where you get a remainder of 0. That will throw everything off. If you do use that, you will see it. Things will not work. You will not get plus or minus 1 as we will see you should get. So if that happens, check that you haven't used that last quotient. Okay, to make a Euclidean table, we make a table with two rows. The first two entries of the first row are always blank, and then the second row always starts with a 0 and a 1. And then we take the quotients from the Euclidean algorithm and we put them in the first row, starting with the last and progressing to the first. And then to fill in the second row, given a quotient value, we multiply it by the preceding cell in the second row and add the one before that. We go through and we complete the table in that fashion. Okay, so we always start with a 0 and a 1. We have two blank cells here. We fill in all of our quotients. We start with the last, go back to the first. And so then I will take Qn times 1 plus 0. That will give me Qn. And then I will continue. I will take the next one, multiply it by what I got there, add 1. And I keep going through. These last two numbers are the ones that concern us. These numbers in the second row should get larger as you go through the procedure. S will be the largest, T will be the second largest. Once we have that, we take S and T and we compute this expression, A times S minus N times T. If everything is worked properly, you should get plus or minus 1. If you don't get plus or minus 1, you've either, as I said earlier, you've used one too many quotients. Another common mistake is that people put the quotients in the wrong order. All right, you start from the last quotient and go to the first quotient. Now, if you get 1, then everything is fine. You just take that value S and it's A inverse. If you get -1, well, then A times S mod N is -1. You need A times S to be +1. So if you take A and multiply it by -S, that will get you the inverse. So if you get a -1, you take this S value and you negate it, mod N, and that gets you your inverse. Okay, so let's start with some examples. Okay, so we're going to try and find 101 inverse mod 1245. We did this example in class working out the GCD for these numbers. So we ran through our Euclidean algorithm, which gave us these 3 successive divisions. I took 101, divided it into 1245, got a remainder of 33. I then took 101, divided it by 33, got a remainder of 2. I then took 33, divided it by 2, got a remainder of 1, and then I stopped. So these values here are my remainders. What I'm interested in for the Euclidean table are my quotients, which are the values 16, 3, and 12. So I set up my table as described. I leave these 2 cells blank. Then I put my quotients in reverse order. So I start with my last one, 16, put in 3, and then put in 12. Then I use that formula. So I take 16, multiply it by 1, add 0, that gives me 16. Then I repeat. 3 times 16 is 48, plus 1 is going to be 49. 12 times 49 plus 16 gives me 604. So the 2 values I'm interested in are 49 and 604. Okay, so I take 604 and I multiply it by A, which is 101, minus my modulus times the second to last number. When I compute that out, I get -1. Okay, so 101 inverse isn't quite 604, it's the negative of 604. So I take -604, I reduce it mod 1245, I add 1245 to it, in other words, and I get 641, and that is my inverse. All right, so we think that 641 is the inverse. If we want to verify that, we can go over to Mathematica. So if 641 is the inverse, I should be able to take 101, multiply it by 641, reduce it mod 1245, and I get 1, just as I was supposed to. So everything is good. All right, now let's look at a couple more examples. Again, we did the GCD work for this in class. So if we go through our Euclidean algorithm, again, repeated division by remainder. So I take 2845 divided by 1578, get a remainder of 1267. Then take 1578 divided by 1267, get a remainder of 311. Lather, rinse, and repeat. Eventually I get down to a 1, and that's where I stop. All right. At this moment, I would recommend that you pause the video and try and draw out the Euclidean table yourself and see what values you get. If you want this to be authentic, pretend that I'm going to leave the classroom and go refill my coffee, which, by the way, is actually empty. So I am going to go refill my coffee, and I'm going to pause this while I do so. All right, now I have coffee again. Let's continue. So if we look at your Euclidean table, it should look something like this. Again, here are your quotients in ascending order from the bottom. and then I've filled in using that rule. 1 times 1 plus 0 gets me 1. 1 times 1 plus 1 gets me 2. 13 times 2 is 26 plus 1 gets me 27. And that's when I'm going to stop doing mental arithmetic. You just keep going. So your Euclidean table should look something like this. All right, so once again, I take these last two numbers. The number I'm trying to invert, I multiply by the larger. The modulus, I multiply by the smaller. All right, so I take 247 times 1578 minus 137 times 2845, and this time I get 1. So 1578 inverse should just be 247. Let's verify that quickly. So we take 247, we multiply it by 1578, and we reduce that mod 2845. And sure enough, we get 1 as expected. Okay. I've mentioned most of these already, but they bear repeating. If you make a mistake, something doesn't come out right, you get something other than plus or minus 1, check these 3 things. So, as always, make certain that you haven't used too many quotients. You stop when you get a remainder of 1. If you use the 0 remainder quotient, it will go completely wrong. Second common mistake, people put the quotients in the wrong order. That will mess up the second row no end. So make certain that you have them in the correct order. The other thing is sometimes people reverse the values of S and T. You want to multiply A, the number you're trying to invert, by S, the larger of the two values. It's the last one, whereas you multiply N by the smaller of the two values. All right, I am going to actually end this video here. There is one more concept to go, so-called Euler-Totient function, or sometimes the Euler-Phi function. I want to put that into a separate video so that these don't get too long and too boring to listen to all in one sitting.